Hello everyone. Today we are discussing about the mutual inductance as well as we are deriving an expression for coefficient of a mutual induction. Here we have a diagram for primary as well as secondary. So here battery is connected across the primary and key is also there at the primary. So when you close the key, current will flow from this primary, and because of that flux is generated in the primary, and the same flux is linked with the secondary, and due to linkage of the first flux with the secondary due to primary, there is current is gets induced in the secondary also, and that we can observe with the help of this galvanometer. Means in short we can say that mutual induction is a property of two coils by virtue of which current flows to primary coil, and hence due to change in the flux across the secondary coil, current gets induced in that secondary coil. So here we can perform an experiment. We have here two coils P1 and P2, and secondary we have S2 and S1, and here S1 and S2 are connected with the galvanometer, where the primary connections P1 and P2 connected with the battery and key, and as current flows through the primary coil through P1 to P2, flux linked with the secondary coil, and due to that there is a current is gets induced in the secondary coil. Okay, so here the flux linked with the secondary coil, we can say that flux linked with the secondary coil is phi 2 and flux linked with the primary coil is phi 1. So here flux is generated due to change in current in the primary, so the generated flux in the coil 2 is directly proportional to the current I1. Okay, and if you remove this proportionality sign, then phi 2 is equal to m into I1. M is nothing but coefficient of a mutual induction. Okay, so and EMF generated in the secondary coil, EMF generated in the secondary coil is nothing but minus d phi by dt. Okay, and here we can substitute the value for phi as we got it here. So I will write here phi 2. So EMF generated due to generation of flux in the secondary minus d by dt of m into I1. So coefficient of mutual induction will remain same. So you can take this as a constant out, minus m d I1 by dt. Okay, so this is the induced EMF in the secondary coil, and if we rearrange the term for the mutual inductance, then we will get M is equal to minus E2 divided by di1 by dt. So this is the expression for coefficient of mutual induction, and the SI unit of this mutual induction is Henry, or we can measure in terms of Weber per ampere, and mutual inductance is defined as a EMF induced in the secondary coil provided the rate of change of current in the primary coil. Okay, and that is also unity. So suppose here if we want the mutual inductance 1 Henry, then the EMF should be 1 volt and current flowing through this is 1 ampere per second. Okay, so in this case only we will get the coefficient of mutual induction should be 1 Henry. Okay, then how to define 1 Henry? So mutual inductance is said to be 1 Henry if EMF is 1 volt is induced in the secondary coil provided the rate of change of current in the primary coil is 1 ampere per second. Okay, so like this we have to define the coefficient of mutual induction. It's very easy and simple concept. So in the last video we discussed about the self inductions as well as self induction of a long solenoid long solenoid, and we derive the expression for that. If you want, you can check my inbox here, so that you will get the link for the last video. And I hope you understood this session, and in the next session I will derive the expression for mutual inductance of a two long coaxial coils. Thank you.